In this video, we're going to use one-sided limits to determine the limit of our given function. Here, what we're analyzing is the behavior of our function at the given value 7/3, coming from both the left direction and the right direction of 7/3. So the way that we're going to determine the one-sided limits of this function is, in both cases, approaching from the left and approaching from the right, we're going to look at what the behavior of the numerator and denominator does as we move closer and closer to 7/3 in the respective direction. We see that in both cases, the numerator of our function will stay approaching 3. There's no value that we plug in for x in the numerator that's going to change the fact that our limit approaches 3 in the numerator. So let's go ahead and write that down for our sake. So we have in both cases, numerator approaches, or in this case is, 3. Okay, so we've taken care of the numerator in both cases of the limit as x approaches 7/3 from the left and the right. But now let's look at the denominator. Let's look at our first instance over here as x approaches 7/3 from the left. In our denominator, we see that if we plug in anything less than 7/3, which is what we're going to end up doing if we plug in any number as x approaches 7/3 from the left, it's going to be less than 7/3 in this case. We're going to get inside of this parentheses here, we're going to get a negative difference simply because there's no number to the left of 7/3 or less than 7/3 that's going to give us a positive difference there. Okay, but even though we get a negative difference inside of this parentheses here, when we square a negative, we get a positive. Okay, so we're still going to technically be approaching 0 from the right, because as we get closer and closer to 7/3 from the left, we're going to see that that difference gets smaller and smaller as a negative number, but after we square it, it becomes positive. So after we take all that into account, as x approaches 7/3 from the left, the ratio that we have is approaching 3/0, meaning the limit as x approaches 7/3 from the left of our function is positive infinity. So that's what we get from the case where we approach from the left. Now let's look similarly for as we approach from the right. We see that no matter what we plug in to the right of 7/3 or larger than 7/3, we're going to end up getting a positive difference. But unlike when we had the case of having to worry about that negative difference as we approach 7/3 from the left, what we have in this case is if we square a positive, we're still going to get a positive. But as we approach 7/3 from the right and get closer and closer to it, we're going to see that our differences in our squares after we square that difference is going to become smaller and smaller to where our denominator is similarly to the left-sided limit. We're going to be approaching 0 with positive numbers. Okay, so let's go ahead and write that down here. So we have a lot of similarities between the left and right limit here. So as x approaches 7/3 from the right, the ratio approaches, again, 3/0, meaning the limit as x approaches 7/3 from the right of 3/3x minus 7 squared, which is our function, is also positive infinity. So we know that if the limit from the left and the limit from the right agree, the limit at our given value is the thing that they agree at. So that means that the limit as x approaches 7/3, 3/3x minus 7 squared is positive infinity.